naive-Bayes analysis. So the learning objectives are number one, we need to understand the concept of naive-Bayes analysis as a classification technique. So we are going to learn thoroughly about classification. Naive-Bayes is one of the classification technique. The second objective, we are going to learn about how the naive-Bayes model work. How the naive-Bayes model work. Okay. The third objective, to use the naive-Bayes technique, in different situations. The last objective for learning the concept of naive-Bayes analysis is you need to know the many advantages and parallelly disadvantages of naive-Bayes analysis. Okay, so we're going to learn a new classification technique called as naive-Bayes analysis, and there are 4 objectives we're going to discuss one by one. Very first one is we need to understand the concept of naive-Bayes analysis. What is this naive-Bayes analysis, or as a naive-Bayes technique? So what kind of technique it is, whether it is supervised or unsupervised. Okay, and it is been called as a classification technique. So we need to understand the whole scenario of the concept naive-Bayes analysis in the beginning. Then, so once we know this, then we need to understand how these naive-Bayes analysis or naive-Bayes technique work. The working model of naive-Bayes we need to learn. The third objective we are supposed to discuss is how to use this naive-Bayes techniques in different circumstances. Then finally we'll see the advantages and disadvantages of naive-Bayes analysis. Okay, so let us quickly do the intro, means the brief on the understanding of the concept of naive-Bayes analysis. As I mentioned, naive-Bayes analysis is a classification technique, right? So naive-Bayes technique or naive-Bayes analysis technique, okay, I'll write it as a short form. So naive-Bayes technique is a supervised learning technique. Supervised learning technique. Supervised learning technique. So when I say supervised, so it has to use the probability theory based analysis. So it uses and it works on a probability theory based analysis. Okay, so this is a supervised learning technique. So that uses Probability theory-based analysis. Probability theory-based analysis. Let us come back to the topic. Okay, and already we are learning the machine learning algorithms or the machine learning techniques. So again, this naive-based technique or naive-based analysis is a machine learning technique. Machine learning technique. Machine learning technique. So when I say machine learning technique, it uses to compute the probabilities of an instance which is belong to each one of the target classes. So we will be given a priority probability of classification using these individual informations or factors. So naive-Bayes technique is also been often used in very much classifying the text documents, into a predefined categories, predefined categories. Okay, so any doubts in this? What is naive-Bayes technique? Naive-Bayes technique is a supervised learning technique that uses the probability theory-based analysis, and it is also a machine learning technique that computes the probability of an instance. Then for a given probability of classification using the individual factors or informations, and naive-Bayes analysis technique is also used often in classifying the text documents into a predefined categories. So let us take a case study to analyze and understand this NBT or NBA, naive-Bayes technique or naive-Bayes analysis. So we all know that there are a lot of fraud will happen. Okay, so many places in our realistic daily life also we see a lot of fraud happens. So how do we do this fraud detection in a government contract? So this is the scenario or a example case study we are talking about for the day to understand a fraud detection in the government contracts. Fraud detection in government contracts. Okay, so this is an example. So this particular is being taken from a US-based city and the US-based government based upon the code. So it is something like they wanted to know the data mining, or they wanted to use the data mining for more efficient and effective use of the resources for the fraud detection in the government transactions. So let me repeat. So they wanted the particular agency or a particular audit person of a court or a government agency wanted to use the data mining techniques for more efficient and effective use of the resources for the fraud detection in government transactions. And they wanted to find out the ways to identify the projects that had very high priority of or very high probability of the fraud. Okay, so in that the naive-Bayes analysis was being designed to assign and to see the risk factor of each of the case. So a naive-Bayes classifier is being designed, okay, to assign a risk factor of each case. So here the audit universe was being set to see the purchases, the contracts, the assets, the programs, the public employees or the contractors. So this audit universe was a set of pairs of public and private parties of all the public contracts as well as the private contracts which are being signed by the particular administration. So almost it was in the total of almost I could say 8 lakh pairs which were allowing and assisting audit agencies in transitioning from the reactive to the proactive fraud detection model. So they were in the design process of that. Then the second thing is the risk factors of these auditing were being identified that it could relate to the entire entity set of the information, and the risk factors were being included in the projects related to the elements as well as the internal elements as well as the external factors also. So in that sense, they categorize the information as the high risk or the low risk. So based upon what criteria they're going to treat it as a high risk. So the competitors, the less competition equal to high risk. The value more money is equal to high risk. A bid protest, more protest means is equal to high risk. So like this, they started categorizing. So based upon the political, economical impact, social impact, the public health, the spend, the timing and effectiveness, like that. So in that scenario of the government contracts, the fraud detection, the naive-Bayes analysis was being used to compute. The naive-Bayes analysis was being used to compute the probability distribution of entries belonging to these kind of risk classes. So there are n number of classes are being identified as I was talking to you. Okay, so one is the bid winner profile, social impact is one of the class, economical impact is one of the class, political impact is one of the class, or the value for the money is one of the class, competitors is one of the class, or bid protest also one of the class, because it's a government contract auditing was being considered as a scenario. So here the probability distribution of all entries are belonging to the risk classes. So they have only two classes. So wherein they treated those classes as one is high risk and another one is low risk. High risk and the low risk. There were only two categories or the two classes wherein they could identify it as a high risk and the low risk. So two values for the each entities were being obtained when they were trying to find out the probability. That is the probability of the high risk and the probability of the low risk. Probability of the high risk and the probability of the low risk. And the probability of the low risk. And these probabilities were being used to compute the conditional probability of the fraud for the testing of almost 8 lakh pairs of the parties of information which were public as well as private. So finally, the probability of the high risk was used to sort the auditable units by the total risk score, and the results were being derived as almost 2,500 pairs out of 8 lakhs. So 8 lakhs was the initially assumed pairs of public and private parties. So in that they could derive that 2,500 or 2,500 pairs of the parties, the public and private parties had a highest risk, had a highest risk. Had a highest risk, and the probability of the score of higher than 99%, higher than 99%, and this result was being included by both the parties with obvious information links like private not-for-profit foundations, for which the government public procurement law was being given in special treatment, and moreover the number of high-risk pairs were being known by the auditors from the previous investigations where the corruption was effectively being found. So similarly, the auditors were found even the derivations of the high risk factors, so which which were effectively found and which were being very reasonable, and they started ranking. So the ranked audit agency was being then used to develop such kind of an audit plan, so wherein they were able to understand so what are the advantages to the government when they could apply this new base analysis for the fraud detection for the government contracts. What are the, who are all the people of that particular government or the sector they belongs to for this analysis, and how could they analyze, and how can the analysis can be improvised also. They were in a position to answer for the questions. And similarly, even a lot of other questions also were being raised and answered. That is, how can they identify another environment where similar to the naive Bayes analysis could be beneficial. So like this, a lot of scenario were being analyzed using the naive Bayes analysis technique. So then we need to understand the particular factor, what we will keep on using it in the introduction to the case study as an example called as probability. So we were getting this word probability. Okay, so what is this probability? So how can we define a probability? So probability is defined as a chance of something happening. Probability is nothing but a chance of something happening. Something happening. Something happening. So the probability values can range between 0 and 1. Okay, so or 0 to 1. And with the value 0, so it will be representing a 1 value. With a value of 1 or the range up to 0 to 1 means, so there is a meaningful description for the same. So if the probability is 0, if the probability is 0, so then we represent that there is no chance. There is no chance. Okay. Then if it is the probability 1, then it will be representing the total certainty. So it will be representing the total certainty. Total certainty. So whatever the previous or the past historical event informations are there as the records, the probability of something happening in the future can be reliably assessed. So for example, one can assess the probability of dying from the airline accident by dividing. It's an example of airline I have taken. So one can assess, we can assess the probability of dying from an airline accident by dividing the total number of the airline accidents related to the deaths in a time period by the total number of the people who are always flying during that particular periods. So these are the probabilities that can be compared to come to the conclusions, such as what kind of the safety measures we can take it, or the safety levels of various event types which are going to occur we can consider. So for example, the past data may show the probability of dying from airline accident is very less than the dying from being hit by the lightning or by the roadways or some other. Okay, so here also the naive Bayes algorithm is a very special algorithm, which I called it as a classification algorithm, is being taken into consideration with the prior probability of an instance belonging to that particular class of airlines, and in addition to that the track record of the instance which are belonging to the class. So then they started making the analysis. Then the word Bayes, naive Bayes. So we could see that the second word in the technique is called as a Bayes. Actually, this is the word refers to an analysis called as Bayesian analysis. Bayesian analysis. Bayesian analysis. So this Bayesian analysis is mainly based on the working model of a mathematician by name called as Thomas Bayes. Thomas Bayes. Thomas Bayes was the mathematician, and Bayesian analysis is being derived based on the work done by the Thomas Bayes. So, which computes this particular Bayes or Bayesian analysis, which computes the probability of The probability of newly or the probability of new occurrence. New occurrence not only on the recent record, new occurrence not only on the new record, not only on the new record, but also on the basis of the past history or the previous experience. Past history or the previous experience. Okay. Then the question comes, what about the naive word? What about the naive word then? The Bayes word we understood. So Bayes is referred to be a Bayesian analysis, which was being based on the work done by the mathematician Thomas Bayes. So which was being used to compute the probability of the new occurrence, not only on the recent records of the recent informations, which also been considered on the basis of prior experience. Then what is this naive word is? So this word naive represents a strong assumption of all parameters or features of instance, which are independent variables with little or no correlation. Naive word represents a strong assumption that all parameters or features of an instance that are independent variables with a little or no correlation. Okay, so thus if the people are identified by their height, so obviously a person can be identified by height, by color, by what do you say for that, weight, something like that. So if a person if a person is identified by the height, weight, age, color, gender, so all these variables are assumed to be an independent of each other. So this is an example. So example of navy is a person or me and you itself. So how the person is identified? So the person is identified by the parameter. One parameter is height, another parameter is weight, another parameter is color, the another parameter, we can have a lot of parameters, but just I'm listing it out the few. So age and gender. Okay, so these are the parameters. So all these parameters or variables, we use it to assume it as it is independent of each other. It is independent of each other. So naive-Bayes algorithm is very easy to understand. Naive-Bayes algorithm is very easy to understand. Very fast it will work. Very fast it will work. Okay, and it also performs well in multiple predictions, such as when the target classes has multiple options beyond the classification like yes or no classification, and naive-Bayes algorithms or techniques can also perform well even in the case of categorical input variables when it is being compared with a numeric variable or numeric variables. So this is about the word naive and Bayes. The next is we need to understand by adding one more letter to these two words called as naive-Bayes algorithm or naive-Bayes model. Before going into that, so we need to understand the model. So naive-Bayes model. So in the abstract, what I could say it as a naive-Bayes is a conditionally a probability model for classification purpose. So naive-Bayes model is a conditionally probability model for classification. Probability model for classification purpose. Classification purpose. So the main theme of this naive-Bayes analysis or naive-Bayes analysis model is to find the way to predict the class variables. So let me take that mathematical notation used to represent the class variable. So class variable y. Class variable y. So which is been using a vector of independent variables, as capital X. So we mathematically represent it as the class variable as y using a vector of independent variables X. So that is, we need to find out a function. F of X gives y. We need to finding the function F gives, that is function X gives y. So in the probability terms, the goal is to find out what? The probability of y by x. So what does it mean? So that is the probability of y belonging to the certain class of x. The probability of y belonging to the certain class of x. So y is generally been assumed as a categorical variable. And with the two or more discrete variable values. Okay. So now given an instance to be classified now, so let us try to see this model mathematically. So let us take that there is a given instance which is to be classified, so which is being represented by a vector as x is equal to x1 comma x2 comma etc. up to xn. Okay, so xn. Now this represents how many number of features, as it has been given as x1 to xn. So n number of features. And these n number of features and all x1, x2, x3 up to xn are independent variables. So naive-Bayes model assigns to an instance. Then the probabilities of belonging to any of the k classes. And the class k with the highest probability is being labeled assigned to that instance. So here we are going to classify it as the highest posterior probability of belonging to the class K is being computed as a function of the past historical probabilities and the current likelihood values, which is being shown mathematically by an equation given as probability of C K bar x is equal to probability of CK, probability of x by CK divided by probability of x. X. Now, we need to understand what are these terms. So, the very first one, what we wrote it in the LHS is P of Ck X. So, P of Ck by X is the posterior probability. Posterior probability. Posterior probability K represents as the class of class K and the given predictor X and the given predictor X. This is the one. Next, the P of Ck. Okay, so here the P of Ck, which is there in the numerator, is given as prior probability. Prior probability of class K. Prior probability of class K. Next is P of X. Okay, sorry. P of X by Ck is given as the current likelihood of predictor given class. Given class. Then we got the last term, which is called as P of X, which is there in the denominator. So this is prior probability of predictor. So this is about the representation as an equation of the posterior probability is calculated as a function of the prior probabilities and the current likelihood value, which has been shown by the equation. And now we need to understand how an example, a simple classification example can be taken, and how can we able to understand this naive-Bayes analysis. So we have to take an example, then we need to prove it. Okay. So this is for the today's class. So what we started with it, so let us conclude. So we started the new technique or new concept which comes under text mining, okay, as one of the data mining technique. So we started understanding this by deriving the learning objectives for the naive-Bayes analysis as the topic. And there are 4 learning objectives we are identified and we are trying to understand one by one. So the very first one, the objective is to learn about the concept of naive-Bayes analysis as a classification technique and how the naive-Bayes analysis or the model work. Then we need to understand how can we use this naive-Bayes analysis technique in the different circumstances, and also we need to derive the compare and contrast, that is what are the advantages and the disadvantages, the pros and cons of this naive-Bayes analysis. So we started understanding the concept of naive-Bayes analysis as a technique. So as I mentioned, the naive-Bayes analysis technique is a supervised learning technique which is been worked based upon the probability theory based analysis, and naive-Bayes analysis technique is also a machine learning technique, and which can be used very much for classifying the text documents into a predefined categories. And we have taken one of the fraud detection government contract as an example to know the probability and the 2 categorical classes with the predicted values as the high risk, low risk, and we try to understand the probabilities of the high risk, low risk for an estimated 8 lakh pairs of private and public activities. So for that, it has been designed and analyzed with the values as 2500 at the high risk and almost it is the 99% of the risk factor. And then we try to derive the word, what is this probability, what it has been frequently occurring in everywhere in the naive Bayes analysis technique. So probability is nothing but the chance of something which is happening, and there are two possibilities of the values. So the probability could range from 0 to 1. 0 to 1. So 0 comes, it represents no chance, and 1 represents the total certainty. And the words we need to understand in the naive Bayes analysis technique as two words, naive and Bayes. So Bayes is nothing but a Bayesian analysis which was being derived by the work of the mathematician, the great mathematician Thomas Bayes, and the probability of the new occurrence is not only a new record, it is also a previous experience of the past experience. And the naive means actually set of parameters and the features of an instance are very much independent variables with a little or no correlation. So we took an example. So how can we identify a person? A person can be identified by his or her height, weight, color, age, gender. Okay, and this particular naive Bayes analysis technique is very easy to understand and very fast it will work. So the working is also very fast. And then we started understanding a bit of mathematically representing this particular model as the probability model for the classification purpose. So we could derive this functionality in the equation for the naive Bayes model. So here we are concluding for today's class. So tomorrow we are going to discuss about the example, a very simple example to analyze and understand this naive Bayes model. Okay, then we will continue in the next class.